Last class, I have seen what is the theorem. In simple random sampling without replacement, the sample mean is an unbiased estimate of the population mean. So sample mean is in simple random sampling without replacement, the sample mean is unbiased estimate of the sample mean is unbiased estimate of the population mean. So this is theoretical statement. So now by notationally, expectation of small y bar n equal to capital Y bar n. So this is what is there by notational. So now how can prove this? So here, what is the notation of sample mean? Small y bar n. Okay, then what is the notation for population mean? Capital Y bar n. So now we have to take the unbiased estimate of the population mean. Okay, so you have to prove that the sample mean, for sample mean you have to take the estimation. Estimation means what? Expectation of small y bar n equal to, you can prove that that value is equal to capital Y bar n. Okay, so now I am taking LHS. So expectation of Y bar n equal to expectation of, what is sample mean formula? 1 by n summation I equal to 1 to n ai into capital Yi. So now I am taking expectation inside. So here ai is called, what is there? Variable. Why? Because ai take the values 1 comma zeros. Okay, so now here first of all I am taking expectation inside 1 by n summation I equal to 1 to n expectation of ai into yi. So this is called equation 1. So now how to calculate expectation of ai, and ai take the values ai equal to 1 comma 0. So 1 means what is there here? Ith unit is included into the sample. Suppose ai value take the 0, ith unit is not included into the sample. So now again expectation of ai. So expectation of ai equal to summation ai into probability of ai. So I think in according to mathematical expectation, expectation of x equal to, what is formula? Summation x into p of x. So summation x into p of x. So x means here 1, and corresponding probability, the probability of ai equal to 1 plus then 0 into corresponding probability of a equal to 0. Okay, so now this is equal to 1 into probability of a equal to 1 means what is there? The probability of ith unit is included into the sample of size n plus 0 into the probability of ith unit is not included into the sample. Not included into the sample size. Okay, so now here that equal to 1 is there as it is. Then what is the probability of ith unit is included in the sample size? That can be written as, what is there? Small n by capital N. Why? Because out of population size, then maybe how to take the sample size small n. So that can be, that probability can be written as, what is there? Favorable case of n by all possible cases plus 0 into, so here ith unit is not included. The total probability minus include equal to not included. So the total probability is 1 minus, what is the probability of included? N by capital N. So the total probability minus included value, then after subtraction, this entire value is equal to not included into the sample. So you can write like this. So now see here 1 into small n by capital N plus 0 into 1 minus small n by capital N. Here 0 is there. So the second term is vanished. then expectation of ai equal to small n by capital N. This is called what is there? Equation 2. Equation 2. So now here again, mm, so expectation of ai equal to small n by capital N, equation 2. So now substitute equation 2 in the equation 1. So what is equation 1? Expectation of small y bar n equal to 1 by n summation I equal to 1 to n expectation of ai into yi. So now the equation 2 value, expectation of ai value, what is the small n by capital N? This value I am substituting in the equation 1. So now expectation of small y bar n equal to 1 by n into summation I equal to 1 to n. What is expectation of ai? Small n by capital N into what is the yi. So now here n and n, both n's are cancelled in the numerator and denominator. The remaining is 1 by capital N into summation I equal to 1 to n capital yi. Okay. So now this entire formula is equal to what is their population mean. So now we are taking expectation of sample mean, and you can prove that what is there? What is there? Capital Y bar n. So this is what is there, proof of the first theorem. Okay, capital Y bar n. So this is the in simple random sampling. In simple random sampling, without replacement, the sample mean is an unbiased estimation of the population mean. Okay. So now similarly, then how can you prove the what is the second theorem? So what is the second theorem here? So what is the second theorem here? In SRSWR, the sample mean square is an unbiased estimate of the population mean square. That is expectation of small s square equal to capital S square. Expectation of small s square equal to what is the capital S square. So now how can prove this theorem? How can prove this theorem? So now see here, what is the proof? We know that small s square, that means what? Sample mean square formula. Small s square equal to 1 by n minus 1 summation I equal to 1 to n yi square minus n into small y bar n square. Okay. So in this formula, then again I am taking what is there? The sample mean. So sample mean, what is formula? 1 by n summation I equal to 1 to n yi. Okay. So in this formula, simply instead of small y bar n, then I am substituting what is their sample mean formula. Okay. So now remaining is as it is, that is 1 by n minus 1 summation I equal to 1 to n yi square minus n into 1 by n summation I equal to 1 to n yi whole square. Then now 1 by n minus 1 summation I equal to 1 to n yi square minus what is there here? 1 by n into summation yi square. Okay. So now here in the next term, then simply here we are adding what is their summation I not equal j not equal 1 to n yi and yj. Okay. So now here summation yi square is there. Then again here also yi square is there. Then 1 by n minus 1 is common. Then here 1 is there. Here minus 1 by n is there. So 1 minus 1 by n we are taking out. Then summation yi square is common for these both terms. Okay. Then again 1 by n we are taking for second term also. Then minus into plus minus. Then 1 by n summation yi into yj. Then again s square equal to 1 by n summation yi square minus So 1 by n minus 1 into 1 by n is both you have to combine. So can be written as 1 by n into n minus 1 summation yi into yj. This is called equation 2. Now for this equation, I am taking both sides. What is their expectation? So expectation taking on both sides, that is expectation of s square equal to 1 by n summation expectation of summation yi square minus 1 by n into n minus 1 expectation of I not equal to j not equal to I not equal to j equal to 1 to n y and y. This is called equation 3. So now consider expectation of summation I equal to 1 to n y square equal to expectation of summation ai into y square. Why? Because so this can be written as like with a constant ai, all I have seen in the previous theorem. Okay. So now here where ai equal to where ai equal to what is there 1 comma 0. If 1 is a equal to 1 means what? If ith unit is included into the sample, then if 0 ith unit is not included in the sample. So now expectation of summation of ai square equal to summation I equal to 1 to n expectation of ai into y square by using what? Previous theorem. So now here what is expectation of ai? Already I have derived in the last theorem. What is there? Small n by capital N. So instead of expectation of ai summation I equal to 1 to n, instead of expectation of ai I am substituting small n by capital N into y square. So small n by capital N I am taking out. The remaining is what? Summation I equal to 1 to n y square. Okay. This is called equation 4. So now let us consider expectation of summation I not equal to j equal to 1 to n yi into yj equal to expectation of c. So here both variable I and j, two different ranges are there. So instead of I range I am taking ai, instead of jth range I am taking what? Aj. So expectation of summation yi yj can be written as expectation of summation ai into aj yi and yj. Okay. So now again I am taking what? Summation outside and taking expectation inside. The expectation of ai into aj equal what is there into yi into yj. So now similarly, expectation of AI into AJ. So like previous theorem, so 1 into probability of AI is A equal to 1 and plus 0 into probability of A is equal to 0. Then again this can be written as what is there? So 1 into probability of A equal to 1 intersection is A equal to 1. Okay. Then again, so here so probability of ith unit is included in the sample plus probability of jth included into the sample of a base. Okay. So now this entire probability can be written as, so what is there? Small n by capital N into n minus 1 into capital N minus 1. N minus 1 by capital N minus 1. So expectation of AIAZ equal to n by capital N into n minus n into n minus 1 by capital N into n minus 1. This is called equation 6. So now expectation of summation yi yj equal to what is there? Summation I not equal to j equal to 1 to n into n minus 1 by capital N into n minus 1. So where yi and yj from equation what? 5. From equation 5, the expectation of this value can be written as what is there? Summation n into n minus 1 by n into capital N into n minus 1. Okay. Again, we are taking summation. So here this is constant n into n minus 1 by capital N into n minus 1. Summation I not equal to j equal to 1 to n yi yj. So this is called equation 7. So now substitute the value of 4 and 7 in equation 3. Okay. fourth and seventh. This both are substituted in the equation 3. So that is expectation of s square equal to, so expectation of s square equal to 1 by n into small n by capital N summation yi square minus 1 by n into n minus 1 into n into n minus 1 by capital N into n minus 1. So that is what is there, summation yi yj. So now here again 1 by n, n cancel here, 1 by n summation yi square minus, so here numerator denominator n cancel, 1 by capital N summation I equal to 1 to n yi square minus, so 1 by n into n minus 1, again n into n minus 1, n into n minus 1 both are cancel, so 1 by n into n minus 1 summation yi yj, that is 1 by n minus 1. What is the remaining here, 1 by n into n minus 1, again so 1 by n minus 1 we are taking out, then what is that, summation yi square into n into y bar n square. Okay, so now as compared with this equation 2 and equation 1 for the small letters, just replacing the capital letters we get the same as above. Okay, so now then what is that, this entire formula 1 by n minus 1 summation I equal to capital N yi square minus n into y bar n square, this entire formula is equal to capital S square. Okay, so capital S square is what, a population variance. Okay, so expectation of sample uh, mean square is equal to population mean square. Okay, expectation of sample mean square equal to population mean square. So this is the another theorem.